So next, we might sometimes have to do a couple extra steps in this. So first of all, I gave you the mean. I gave you the average on the first couple problems. That is not always going to be the case. You will not always have the average. I also gave you just a few pieces of data. Sometimes you might have to do this for larger data sets. And so when you're doing it for a larger data set like this one, you have to integrate the frequencies the same way that you would need to for some of these other problems. So I did not write out the step by step of this. You need to watch the lecture to see how I get to each one of these values. So watch this next chunk of the video and I'll walk you through how I got these from this list. Okay, so to start, we are going to calculate our average because we don't have that yet. So in order to do that, we're working with a frequency table. That means that my sum of x is going to be frequencies times data values. So 25 zeros, 32 ones, 24 twos, 13 threes, and 6 fours. Okay, so that's all our data values. In terms of how many data values, if we add this up, where's my calculator? We've got the sum, well, actually, let me write it out. So n is the sum of f. So 25 plus 32 plus 24 plus 13 plus 6. If you write it out this way, you make sure that you're not skipping anything and you can see where it lines up with the frequencies above. So it's kind of a good idea. So 25 plus 32 plus 24 plus 13 plus 6, that gives me 100 on the bottom. So x bar equals, on the bottom we have it down to 100 already. On the top part here, 25 times 0 is nothing, so I'm going to not count that one. But then we've got 32 plus 24 times 2 is 48, plus 13 times 3 is going to be 39, plus 6 times 4 is going to be 24. Okay, so we've got the multiplication piece of that top part. Again, in terms of the grouping symbol stuff, so there were kind of invisible brackets here and here. We took care of this bottom one, got it down to a single number on the first shot. Here we had to multiply first. Now we're going to do the addition part. So 32 plus 48 plus 39 plus 24. We already know that when we calculate this final value, which that gives you 143. When we calculate this value for x bar, it should be within this range from 0 to 4, because otherwise it doesn't make sense as an average. And when we divide this, we get 1.43. So cool. That's what we need. We need something that's in this range. That seems logical. It's kind of toward the bottom end of the range, which you can see from the frequencies. It trails off in the frequencies up toward the top. So this is right skewed. Is that right? Yeah, right skewed. So even though the data are clumped here, it's still pulling the mean a little bit away from it. So the data are kind of clumped at 1 and it's pulling the mean a little bit past 1 to 1.43. So I'm going to write that up here. That is an interim value we will need. That is not rounded. That is the exact value. If it went on beyond that, if it was like 1.437, I would include all those digits. It would be annoying, but I would do it anyway because that would give me the precise value. So that's our average. Next, we need to do this formula, but in the same way that we multiplied the x's by frequency for the average, we need to do that again with these blocks. So for this kind of situation, the sum of squares ends up being the sum of the frequency for each x value and then x minus x bar squared. But we don't write it that way because technically just writing it this way already tells you you need to repeat this once for every time the value occurs. So just putting the frequency in front of it is the way to get the accurate sum. So in order to write this one out, we need to take 0, 1, 2, 3, and 4 and subtract the mean from each of them. But we also need to include the frequencies. So I'm going to start with, I've got 25 zeros. I subtract 1.43 from that, square it. I then will have 32 ones. Gotta subtract the 1.43 from that and square it. You cannot do the multiplying first. Order of operations gets really important here. Let's see. We've got 24 twos. So plus 24 times 2 minus 1.43 squared. And then let's see, 13 and 3. And then I got to put 1 down here because I ran out of room, but that's okay. We've got 6 fours. So 6, um, 4 minus 1.43. It really matters where the data values go. The x's have to be in parentheses. The f's have to be out of parentheses. Otherwise, everything will get wonky. Okay, so that is our top row. That is this piece expanded. Pretend it's all written out in one pretty strip. On the bottom, we've got n minus 1. So let's see. What did we get when we added all that up? It was exactly 100, right? Okay, so 100 minus 1. If I leave this as is, that's variance. If I take the square root, it's standard deviation. So there's our full formula. Okay. The bottom part of this, again, this division bar tells us treat the top and bottom separately. Bottom part's easy. We just subtract and get 99. In here, we need to do all of the subtraction pieces. Now, I am going to switch over to a spreadsheet and show you how to do some of this stuff in that as a calculator as well. Because once you start getting into these formulas where we have repeating pieces like this, it can be really helpful to know how to navigate it in a spreadsheet. But then I'm going to show you how to come back here and write it out on paper. The spreadsheet, again, can use it as a calculator. Are there automatic functions to calculate some of these things? Sure. But the point right now is for you to understand the calculations and be able to do them. And so I don't want you to use automatic functions. I want you to use the spreadsheet as a calculator. We'll talk about the automatic stuff later. So let me get this set. Okay. So the top part of the standard deviation formula, what we want, what we would like to do, and what we could do entirely by hand. Whoop, did I stop the share or did I hold up? There we go. Okay. So what we sorry, my screen view is wonky. What we want to be able to do is we want to first do the subtraction part, so calculate the deviation, then actually I lied. Then square it. Whoop. So we get the squared deviation, then times the frequency. So first the deviation, then the squaring. That's the part that you would normally do if you weren't working with frequency and just had individual values. But then multiply that value by frequency. So you calculate the squared deviation first, then multiply by frequency. So the deviation part, we're going to do this value minus, and I'm just going to type in 1.43 because then when I drag this down, it'll keep, since I actually typed it in instead of clicking on something, it keeps that 1.43 and then just like drops down what value is it's doing the subtraction with. So the deviations are these. That would be the first step. That would be what I would rewrite back in parentheses if I were working on the board, which I'll go back to that in a second. Then we square them. You can either click on a value, use the little up caret thingy above, it's usually above the 6 on the keyboard, and then hit 2. That says raise this number to the second power, which is the same thing as squaring. Or in the same way that like repeated addition is just multiplication, repeated multiplication is just an exponent. So squaring something is the same thing as multiplying it by itself. So in here, you can also just do that. Type that in once and you can drag it down. I do not want to round these because I'm not done with them. So I don't want to round them. Which this is another reason why doing some of this in a spreadsheet can be nice because it's kind of a pain in the butt to write it all down. But as long as you understand the steps that you're doing in the order you're doing them in, you're kind of okay. And then here we do the squared value times the frequency. So this is the squared deviation times the frequency for that x value that you made it from. And we end up with this. Okay. We can then get our overall sum by taking the sum of these values. Oop, it did not like that, my bad. Of these values. Okay, so we get 136.51. This number is not being rounded. Okay, if I keep expanding it, it just adds zeros onto the end. That means that it actually stops at the 5, 1, even though these numbers up here don't. That's because some of these kind of have a complementary effect and cancel out some of the little trailing ends here. Anyway, so you get 136.51 as your sum of squares. Where's my marker? Okay, so I'm going to write that down up here, but then I'm going to also kind of translate some of the stuff up onto the board here, so you can see how this works with the written part. So I just did these calculations, right? Um, if I translate that back to the board, so the deviations when I did this part, I ended up with 25 times, the first one was negative 1.43. I still needed to square that, and then 32 times negative 0.43. Now, I'm not actually going to write out the entire thing. I'm going to put dot, dot, dot to show that you would do the same thing for the others. So that's where those values are integrating in here. Okay, then we don't touch the frequencies yet. Let me put the rest of this formula back on. Uh, okay, we're not going to touch the frequencies yet. We got to square this first. So we square and we end up with, let's see, this one squared gives us 2.0449. And then, whoop, need the 25 in front of that. 25 times 2.0449. And then plus 32 times our next squared deviation was 0.1849. And then we would keep doing that for the other several values. Still have the divided by 99 here. Okay. Then we can do the multiplication piece. Okay, so that's where our 51.1225 and our 5.9168 and all the rest of those values would go on that next line. We still just have this divided by 99 thing going on underneath. Okay, so if we had all the rest of those values listed out there, again, then when we add this up, that's where we get our 136.51. Okay, that whole thing in the spreadsheet was just for this chunk of the formula, sum of x minus x squared, the sum of squares. Okay, we then still need to continue from there. We divide the sum of squares by our n minus 1, which I could pull the spreadsheet back up and do, but I'm just going to do it on my calculator since it's not that much to type. Divided by 99. So that gives us a variance of 1.3, well, make that less ugly, 1.37, and then it just goes 8 repeating forever. Okay, so what that rounds to is going to be, well, don't want to round it yet. I need to take the square root and then round it. So when I take the square root of that number, which if you type it into a calculator rather than just doing it directly from the thing, you would want to type in like 1.37, do at least 1.3788. And when you take the square, hold on, I'll retype that in, 136.51 divided by 99, take the square root, and you get well, really you get 1.174 craziness, but I'm going to put 1.17, and I have the little squiggly symbol there to show you that it's approximately equal to and not exactly equal to. Okay, so our variance was 1.38, and when I'm reporting it, variance squared. When I'm reporting it, I can round it to 2 decimals, even if I keep all those decimals for taking the square root. My standard deviation is 1.17. Okay, so that is that one.